Okay, we're live, and lesson 7.
Yep.
And did anybody have any questions about the homework this week?
Nope.
No.
Okay, let's get started. Everybody want to open up the quiz if it's not already?
Got it.
Perfect.
It is 15 questions long.
Yay, hopefully it's not because this one is going to take 15 minutes. I'm just going
And
to...
you'll need the normal probability applet again.
Okay, cool.
So there's a link in it.
Perfect. So there are a couple of weeks where I'm going out of town. So I'll let you guys know what days those are, and then kind of if somehow if we can't meet up, then I'll just send somebody information on how to start these live videos.
Okay, sounds good.
Awesome. Okay, starting with question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. God, years, yes, compared to the 3 decimal places. Eight.
I got 0.175.
In between these two?
Yeah. Would
Yes.
Yeah. Okay. 0 point. I'll start that answer key in the...
Wait. Oh, I see. Okay. Sorry, you guys are right.
Yeah, it's combined, so you need to
So it's 0.1745.
highlight both. Uh-huh.
Cool. Got it. So it's 0.175? Yeah.
Awesome.
Do you want me to go next?
Wait,
Yeah.
wouldn't it be 0.825? Because isn't it the area between them, not the two areas on the outside?
Right. Yep.
That's what I was thinking. That's why I was confused. But it says under and to the left. To the right of the 1.35 and to the left of negative. So we were right.
Oh, okay, yeah.
That's what
So
I
it's
was
not-
confused. I was like, wait, it's in between, but it's on the outsides. So it's just confusing.
Yeah,
Yeah, that makes
We'll
sense.
set it in as a confusing way as possible.
Yeah.
Yeah.
Okay. Question 4.
I can do it.
Okay, cool.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? So n is 9. Right? And then
Yes.
distribution of the individual observations.
Let me...
Wouldn't the standard deviation get smaller if you use 9? So it would be the first one, right? I think it's the first one. Because it's saying which one would be smaller standard deviations? Would it be the one with the individual observations, like the N9, or the distribution of the sample means, which is everything normal? I think.
I'm pulling up the textbook. Unless
I was thinking maybe the first one too, but I'm not quite sure.
I don't know if we have enough information to determine that.
But if we have a 9 and we use the standard deviation is standard deviation over the square root of n, wouldn't that make it smaller? no matter what n is. If n is there, it's going to be smaller than if it wasn't there. You would just use the
Right.
normal standard deviation.
Right, right.
Okay.
Even though it
I-
doesn't give us a standard deviation, I think it would.
No matter
Still
what it
is.
was. If
Yeah.
it was,
Right. That makes sense.
what if it was
I
zero?
guess it could be the same thing if like the standard deviation, the n was 1. It would be the same thing, but it wouldn't be enough information anyway. So
Okay. So A, and then let's do it again. Then we know.
yeah.
Not enough information. Okay. Katie, do you want to?
Sure. Question 5. Which of the following results implies that the spread in X decreases as the sample size increases?
So it's talking about standard deviation? Like if the spread wise?
Yeah.
So as the mean decreases, as the sample size increases.
I think that's
The
the law of the large numbers, because according to the definition here, for large law of large numbers, it says
gets closer to the mean.
yeah. As the sample size n increases, the sample mean draws closer to the mean, to the population mean.
But that's not the mean decreasing though either.
Let's see.
Need to look.
Would it just be normal distribution then? Because there's always going to be decreasing ones on the edges.
Yeah, I think that if the sample size increases, it's going to be more normal. But that doesn't, I don't understand what they mean by when mean decreases. That's just confusing. I don't understand that.
I guess as the mean gets closer to the population, the I don't know, the
Does
shape,
the
mean gets smaller.
but how does the mean get smaller? That's the problem. Like I've never seen the mean change unless
Well, not
you're like
smaller.
changing the data.
I guess the more samples that you have, the less deviation
The
there's gonna
closer
be
you'll get to the mean.
Yeah. But does that mean that the mean's decreasing? Maybe I'm
I
just
don't know, it's like worded weird, I guess. Right?
I might just be overthinking this. But how about we skip this one and come back to it? Then
Okay.
then we won't spend too much time on it.
Okay.
Okay,
Yeah,
I'll do number 6.
My
Oh,
brain was
sorry.
like not working when I was like, okay, I need to send this out. So I feel like maybe we just need a little warm up.
I'll read number 6.
Okay.
Scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation of 8.8. So the question is, Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay.
I got 1.045.
Yep, I got that too.
Does everyone else get that? 1.045?
Yes.
Yeah.
Taking the mean, subtract, well, the amount, 160, subtract the mean divided by standard deviation.
Yeah.
Cool.
Can I just
And-
ask a quick question? My computer just did this weird thing and changed my answer on number 4. Which one did we decide that one was?
A.
Number A, yeah.
Okay. Thanks.
I'm putting the answers in our chat if anybody
Oh, okay.
wants to. I don't know. Maybe it's just for me.
I see it.
Okay, question.
7?
Yep. Here we go. What is the probability that a randomly selected student will score above 160 in the quantitative portion of the GRE?
So you would use a z-score in the applet that we just found, right?
Yeah.
Yeah.
So score above it or below it? What did it say?
Above.
Above
yeah.
it. So that would be 0.148.
Yeah.
Yeah, that's what I got.
Mhm.
Sweet.
Alright.
We're getting there. We're moving. Like, oh, is it my turn? Sorry.
No, that's okay.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? Okay, so the sample mean, so that's N5, right? Round your answer to 3 decimal places, blah, 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 blah. But they don't give us the z-score. Which one to find the z-score for?
Don't you just have to add that and get the? I got 160
For the average,
mean.
yeah.
But it wants the z-score.
So we'll do the same thing we did on question what? Question 6.
But with what number? Do they want to do 160 again? Or
We can find.
they don't really specify that.
Can't we find the mean?
Yeah, it's asking what's the z-score corresponding to the sample mean. So I guess the mean is 160, and then
Yeah.
we'll just get the z-score, right?
Yeah.
Oh, I see. But it's the same thing. Oh, wait, but you have to take the 8.8 divided by the square root of 5, right?
Yes.
For the standard deviation. So you would take the 160 minus 150.8, all divided by 3.9354.
But remember that this is a random sample, so we don't really know the.
Well, they gave us the mean earlier. They gave us the original mean. I think they want us to use this sample data for like
Yeah, it
n
says-
equals 5.
Yep.
And use that mean of the 160. Because when we added them all together and divided by 5, it was 160, right?
Yes.
Then we just use that one for the value or the x, the one thing. Yeah.
So wouldn't it be the same answer for number 6?
No, because we're going to take you remember
Square root
the
of
equation we learned last time? That we're going to take the square root of 5. So we're going to 8.8 divided by the square root of 5. Do we remember that equation? The standard deviation divided by the square root of n? Do you remember that?
Yeah.
Yeah, I think that's what we're doing. And I got 2.337. But I want to make sure you guys got the same thing. Did I just totally confuse you guys?
No, that's
I'm
one
just
of
trying
the.
to work it out in my
But I'm
brain.
not sure if they're asking for the mean of the mean. Let me see what it's called.
Because where they get the sample mean is from this sample, right? So you get the mean of this sample, and that's your new sample mean. And you're going to take that sample mean and subtract it by the original mean and divide by the new standard deviation, which is the 8.8 divided by square root of 5. Does that sound right to you guys, or?
Yeah.
Okay.
Yeah.
I don't know. I'm a little bit confused about using that formula. I don't know if I don't know if it's
Because it's asking for the z-score. So the z-score formula is value minus mean over standard deviation.
Can you see it?
You have to talk for us to see it.
Can you see it? Can you see it? There's on the right, I think, or whichever, there's the standard deviation over the square root of n, and then there's also the value minus the mean over the standard deviation.
Yeah.
And I just use both of those to find. Did that look right to everybody?
Yeah.
Okay. I like chalk. It's wonderful.
Okay, standard deviation.
So what did you guys get for your numbers?
I got that 2.336.
336? I got 2.337, and if you round up, it's 8. Did you keep all the decimals in your calculator?
No, I didn't keep
Okay.
all the numbers after the decimal.
Okay,
So
that's probably why.
why.
Did anybody else get 2.338?
No. I'll try that again. No. So I'm doing 160 minus 150.8 divided by 8.8.
So you want me to show you what I did? I just wrote it again. Okay, so let's see. Hello, can you see it?
Yes.
Da-da-da. I could keep talking. 160 minus 150.8, which was the original mean that they gave to us, divided by the standard deviation over square root of n, which is 8.8 over square root of 5.
Oh, I was just doing 8.8 divided by
Okay.
8.
Does that look right now, Lydia, to you, or?
Yeah, I mean, I know that formula, but you know, the question is asking for the z-score corresponding
Yeah,
to the.
and we just, this equation is the z-score. It's the v minus the mean over standard deviation. Do you see
The
that
value, yeah.
over there?
Yeah.
This one. Yeah, that is the one, that is the z-score.
So that's all I was finding.
Yeah, and so what you need to do is use their sample mean, which is the 160, which we found by finding the average of
Wouldn't
those.
that be, instead of the x bar that you put, wouldn't that be the mu?
That's what
The
means.
X bar means mean. Sorry, I'm all techie on my. It's the mean.
So, okay, I guess this is my question. If it's asking for the z-score, why don't we just do 160 minus 1 over 8.8?
Because it says what's the z-score corresponding to this sample mean.
That's
That's
how
what
we
it is
use
tricky.
n, so you always use that equation for it when
Yeah.
it says n.
Yeah. So it doesn't say n, but it says 5 samples, which is the 5. N equals 5.
Great.
Okay.
Right, okay.
All right. So what did everyone get for their numbers? Just make sure. Because if I got it wrong, then it'd be. Maybe I'll plug it in again. 16 minus. Divided by.
What does the X bar one stand for again?
It's the mean,
The mean.
and the little omega symbol, that's the, I don't know what it's called. I think it's omega.
Yeah.
Sigma or
That
something?
one,
yeah.
it's either sigma or omega, I don't remember, but that one is the standard deviation. And then n is your sample mean, and then the v is just value, z-score is z-score.
Are you sure the X one is the mean? Because up farther it has the little U one as a mean.
I think they're both the mean. It's just
Yeah.
in the formula they use the bar, and in when they're giving you the information they use the U, which is weird. I don't know what it is,
I'm
but
just curious because on the equation that I wrote down from the book for that equation, it has X bar minus U.
oh,
So it might be flipped, but I'm not sure if I'm right on
I know it's the value minus the mean, but I don't know the actual symbols for it. I just made it up.
I know. I always just write it out because I'm like these symbols. I just write that.
Yeah, the symbols are confusing. So
that.
Okay.
Yeah.
it's the value minus the mean, though. I do know that.
So didn't we put the mean in first? So don't we need to switch it?
We put the
Isn't
value in
160
first.
the mean?
No, that's the sample mean, which is our value at that point in time.
Oh, okay.
I think. I'm pretty sure.
150.8 is the other mean. Okay,
Yeah.
I get it now.
I was thrown off. I'm like mean, sample mean. Are we? Okay. So did everyone get 2.338?
Uh-huh. Yep.
Lydia?
Yes, I got that too.
Okay.
Sweet.
All right, I can do the next one if you want.
Okay.
Cool.
So that would be number 10, right? Yeah.
Number 9.
Oh,
Yeah.
wait. Oh, yeah, that's right. Okay. So what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So the mean is 160.
The sample, yeah. 160.
What is? So we are using the z-score we just found and plugging it into the applet?
Yeah.
I think so. Yeah.
Okay, I was like, that's what it looks like, but I'm not sure. So 2.38.
So greater than, right?
I think it says greater than. Yeah, greater. So it's really small. It's 0.0097 or 0.010.
I think it is still
If we round it.
3.5.
So it's like 0.01. Wait, it says two.
That's
It says 4 decimal
It says
places.
4, so it's going to be 0.0097. Was that what it was?
Yeah, I think so.
Okay, yeah.
Yep, I learned.
Does that make sense? Or are we grabbing the wrong z-score?
I think that's the right one.
I think so. Okay, let's go with that.
I'm willing to bet it's 3.5.
So are you using the 2.338 and
Remember,
plugging
right,
it?
there's one in the preparation assignment.
Yeah, we are plugging it in the applet.
So what did you get again? I'm sorry.
0.0097.
Oh yeah. Okay.
And we're going to round to 4 decimal places, according to the question.
Okay, then that makes me feel like we got it right.
Yeah.
Right. Okay.
Number 9. 0, 0.
Should I go ahead and read this one?
Sure, that was
Okay.
Wait, what? Yeah, go. Sorry.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who are selected?
So there's 81. N is 81. Okay.
mean is 3.5.
So we do 3.5 divided by square root of 81, which is 9. So, wait, if this is,
Isn't it just going to be normal?
Oh, so right here.
Because it's
it
over.
says left skewed though, And it's gonna be normal. Approximately normal.
Right.
Because it's over 30.
Right.
Mhm.
Okay.
Sweet. We were overthinking that one.
Okay. I will read question. Or Lydia, do you want to read question? Who hasn't gone in a while? I don't know.
You.
Question. What is the mean of the distribution of the sample mean from all populations size 81 that could be drawn from the parent population? Round your answer to 1 decimal place.
So we're using information from the, yeah, okay, sorry.
Sorry.
So it's asking for the new mean with the sample stuff?
So it's like what we did on that other one.
3.5.
So we do the mean, which is 3.5. Wait. Divided by 9
Okay.
would be the answer? The new mean or the new standard deviation?
What is the mean of the distribution?
Or would it be,
No, I think
because that means it would be 0.4, which makes somewhat sense. But
Wouldn't we have to do the square root of 81?
which is
Standard deviation?
9, right?
yeah.
Oh, sorry.
That's okay.
I'm not done with the calculation.
So, what is the mean of the distribution of sample means?
So how exactly are we doing this?
Yeah, that's what I don't even know.
So it's either 3.5 or it's 0.4.
I think it's 0.4.
I think so too, because I don't think they would just leave it the same.
Yeah.
I think they want the new,
So are we on 13 now?
the new value that you're plugging in because of the n equals 81 thing.
This one would be the 95.
So can you walk me through?
So point.
Yeah, because I don't get how to do it.
Wouldn't it?
So just like we did last time, we took the standard deviation divided by the square root of,
Well, it's the.
oh wait,
It's the rule of like it's the 67.
that doesn't make any sense.
Point something and 97.5.
What would be the
This is only one standard deviation.
value? It's not telling us the value.
Yeah, there's not a value, so we
Yeah.
can't. But I can find the new standard deviation. It would be 0.08. Well, that wouldn't work, so it'd be 0.1 technically.
I know that's fine. Yeah, 0.077.
Yeah. So 0.1, if you're looking for the new standard deviation, if that's what they mean.
Which I don't.
Sampling distribution.
Let's look at the textbook.
Yeah.
Review of sampling distributions, right where it popped up. Okay. For the mean of, I'm gonna just screen share this with you guys.
Sure.
Wouldn't we need to solve for x right here on this one?
Oh, we have to find the value.
Yeah, so the standard deviation of a random variable is x is, okay, so that's what we already got. We have a random variable. They're having, in this, I don't know, they're just having us look at the,
It says it right here. The standard deviation of the random variable x bar is omega over square root of n.
right,
So that's the standard deviation. It says the mean of the random variable x bar is u. but how do you find v?
I got 2.8, but I'm not sure if that's the right answer.
Did you get 0.8 or 0.08?
Actually, I got 2.8
Oh, 2.8.
because what I did was, the formula x, the value minus the mean divided by the standard deviation.
What value did you use?
I didn't have any value because we're solving for x, right? Or no?
But we don't have the z-score either of the value.
Oh. Yep, you're right.
So that's where it's hard to solve for anything, because you don't have all the variables.
Yep, you're right.
I'm pretty sure we have all the variables. We just don't know that we have them.
Yeah. I think that this is an equation that we don't know. Like, I think that it's just going to be a matter. We're going to.
Because I'm reading number 3, the probabilities involving a mean, and it's talking about the z-score.
It says, okay. So this one says, I think we have to use the normal probability applet. Can we find the z-score?
Of what? What are we finding the z-score of? That's the problem. Of n equals 81? Because we can find the standard deviation. But without a value, we can't find the z-score, and without the z-score, we can't really find the value.
Well, we're using it says for the next 5 questions. So we have GPA, the random sample. Isn't the value 81?
Well, that's how many, that's n. We have the mean, the standard deviation, n, and that's about it. But do they want us to find the z-score?
Should we come back to this one?
Yeah. Probably good.
Yeah, because
12 might be just this. What is the standard deviation of the distribution of sample means for all possible samples of size 81 that could be drawn from your parent population?
Wouldn't that one be the 0.077778 one?
I think so.
Yeah.
That's just
So it'd be
standard deviation.
0.078.
Yeah. And if we're wrong, we'll know.
Yep. What is the probability that the mean GPA for 81 randomly selected BYOI students will be less than 3.3?
So we have to be able to find the z-score somehow.
So if we use we use 3.3 as a value,
Then we can do it.
minus the 3.5 divided by our new standard deviation, which was the 0.07777 thing. And I got negative 2.57. I'll go plug it in.
And that would make sense because it's less. Right?
And it's going to be less than? What is it looking for?
less than
3.3. Okay, that's a really small number.
0.0051.
0.0051, yep.
And it asks us to round to the.
So 0.005.
Yeah. 005.
Does that look right to everybody?
Yeah.
I think so,
I think
yeah.
so. I have no other clue.
I know, I'm like so lost.
Question
Oh,
4.
then the other one's greater then, so.
Okay.
Oh, just click on the new one. So that would be just 1 minus that, basically. So it would be 0.9949 or 0.995.
All right. Yeah.
Something happened. There we go.
So it will be 0.9945, right?
Mm-hmm.
Uh-huh.
Who wants to read the next one?
I'll read it.
Sorry.
What is the probability that the we're doing 14, right?
Oh, sorry. That was
Now 15.
Oh,
we're on
boy.
15.
Yeah.
Which one? So we left number 11 blank, and we moved on.
Yeah.
And then 12, we got the 0.078.
Mhm.
13, we got the 0.005, and 14, we got the 0.995.
Oh, okay. Sorry.
My fake,
okay.
my assumed answer key.
Okay.
We don't know.
So the last one is the United States Coast Guard assumes the mean weight. So this is a different one, right?
Mhm.
Yeah. Okay. The mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passengers' weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample.
So we're going to use that 177.6 as the value, right?
Sample.
Find the z-score to get the probability
Yeah.
out. Okay.
Yeah, this is a lot. 177.
And we're going to use the original mean, which is 185, divided by 26.7 over the square root of 48.
Can you show us that?
Oh yeah, one sec. It's really bad handwriting, but we'll just go with it. Hello, can you see it? Right there.
Yeah.
Okay, that's great. So the 177.6 minus 185 all over 26.7 over the square root of 48, which will probably be something under 7.
Yeah. Square root of 48.
Yeah. I got negative 1.92. Did anybody else get that? Did anybody else get negative 1.92?
I'm working on it.
I'm sorry.
That's okay.
Negative 1.92, you said?
Yes.
Yeah, that's what I got.
Okay. And it says, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed. Oh, so it's going to be above and below those two
Yeah.
numbers. So stuff not in between, which is 0.0549. Did everybody get that one?
Yeah.
Sorry, I'm going fast.
0.055, yep.
Yep, 0.055. We should read this note. One second. As extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also the ones as far away from the mean as are as possible. Okay, yes, that's what we did. Cool.
So 0.055.
Yes. All right, let's go back up to 5 and then do 11. Or should we do 11 and then do 5?
Let's do 11 since that's gone up there.
Because it's more recent. Let's do it. Okay. What is the mean of the distribution of the sample means or sampling distribution for all possible samples of size 81 that could be drawn from the parent population? And the parent population was... Where's the parent population? This was a long time ago.
It's just right before question 10.
Oh yeah, the 3.5 is the mean, 0.7 is standard deviation, and random sample n of 81. Okay. So I'm gonna write this down. So what is the mean of distribution? Mean of distribution of the sample means. Okay.
I'm looking at distribution of sample mean on Google.
Okay. Because it looks like we do the same long process of doing the sample means minus the mean divided by the standard deviation over the square root of n. But the problem is we don't have a value. And the value should be the mean of distribution,
Okay,
I think.
I have a standard distribution calculator. And it asks for the mean, the standard deviation, and n.
Sweet.
So,
Does it say how to use it though?
I know. Well, let's see what they say it is, and then we'll see how they got that.
Okay.
We could probably figure it out after we know the answer.
Yeah. I
I'm
think
pretty sure it's the same way. So it's probably negative 3.5 over 0.7 square root of 81. It's probably a negative. If it's negative number, let me know.
I'm just gonna screen share this with you guys because I think this is ridiculous, but I don't. Doesn't make sense to me. Can you guys see me and all my calculations? So mean value,
Oh,
standard
wow.
deviation,
Whoa.
but
Keep talking.
okay. Oh, so I don't really know what any of this means, and I don't know if by number of points to generate, if that would be 81.
What number does it say in the bottom?
Mean sample value says 3.585. But I think that number of, yeah, and then standard sample deviation.
So they're looking for the new mean, basically.
Yes.
But how did they find that?
No idea.
Maybe I should look it up again in the book.
Yeah.
I'm gonna look again.
The distribution of sample means. What the freak does that mean? For all possible. Okay.
Let's go to summary. Review key concepts.
Okay. The mean of the sampling distribution of the mean is the mean of the population from which the scores were sampled. Therefore, if a population has a mean U, then the mean of the sampling distribution of the mean is also U. The symbol HM is used to refer to the mean of the sampling distribution. Therefore, the formula for the mean of the sampling distribution of the mean can be written as UM.
What was the formula?
UM, it's basically saying It's basically saying that the mean and the sampling and the mean of the sampling distribution is the same.
That's what I thought, but it seems so simple.
Right? So,
So it is
Round to
3.5.
I think it's 3.5.
This is gonna be funny if it took us all that time and it really is just 3%.
Try that,
But that's the mean, right?
right? You guys want to just try it?
Let's just
Might
try
as
it.
well.
Let's go with 5.
But yeah, that website said the mean of the sampling mean of the mean and the mean are all the same as the mean. So,
That's annoying.
okay, question 5 reads, which of the following results implies that the spread in X decreases as the sample size increases?
Oh, I remember this one.
So when does the mean decrease as the sample size increases?
So as n gets bigger,
Yeah.
n gets bigger. Okay, let's just go over what all these answers mean.
Yeah.
The normal distribution is just bell-shaped. We know that.
Yeah.
The 68, 95, 97 rule also fits with bell shape, which is normal. So I don't think it's either of those because those are basically the same answer. So it
Yeah.
probably is the central limit theorem or the law of large numbers. So central limit is the more you get, the more bell shape it is.
Yeah.
Then the law of large numbers is the larger you get, the closer you are to the mean. Right?
I think it might be central limit theorem.
Okay.
I don't know, because it's like, which of the following results imply this? The spread of the mean. So it means the mean stays in one spot. It doesn't, it's not all spread out.
When it says the spread of the mean, isn't talking about the standard deviation.
Yeah, so it's saying
Because the
that
bigger the sample size, the smaller your standard deviation.
it's true.
Is basically what it's saying, right?
I think so. So would this be the central limit theorem then? Because it's worried more about the graph format,
So
like
what's the
how
answer for
it's
8?
all focused towards the mean versus the law of large numbers.
2.388.
I don't actually know the law of large numbers. I don't know what it is. It's like the more you get,
It is.
And that's the z-score.
more normal it becomes probability-wise.
Law of large numbers, it says if the sample size is increased, then the standard deviation of the sample mean will decrease.
So
So I
this
think
is like a toss-up. Like, honestly.
it's increased.
But if you read the definition for the spread, because there's shape, center, and spread. It says if the standard deviation of the population is
Okay, that makes sense.
standard deviation, then the standard deviation distribution of the sample means is standard deviation over square root of n. Okay, so then in parentheses it says the standard deviation of the distribution of sampling means
do you need
would
us to
be
go through the
smaller
answers for you again
than
so
the
you can
standard
mark them?
deviation of the population.
I think it's law of large numbers.
Yeah,
Yeah,
that's what
I
it
think so
sounded
too.
like
Yeah.
after hearing that definition.
Standard deviation.
Yeah.
Okay.
I don't know the difference between them, so you guys, I don't know this one. So I'll go with law of large numbers.
Yeah. I think that's what it is.
Okay, we ready to turn this in, guys?
No, not yet.
So for the last one, it's just, or actually for number 11, it's just 3.5.
Yeah, like that's the only thing we figured.
Okay.
And I figure since it says 1 decimal point, maybe that's a context clue. I don't know.
Yeah,
Yeah.
Okay, shall we?
let's turn this in.
Come on.
Come on, lovely.
We missed one.
Which one?
That's not bad.
Which
I know, like I don't even want to go back and do it, but we can.
it was question 4.
4.
The
Yeah.
yeah.
Which of the following will have smaller standard deviation if 9 observations are randomly drawn from population?
But you guys, we did so good.
We did really good.
Like all of the film
Got all the right numbers.
Yeah, so what do we think that
Good.
number 4 is going to be then?
maybe not, can't be determined.
Probably. 'Cause that's
Actually,
what we're
no,
thinking.
no, because I put that and it's wrong. So
Oh,
which
so
one
it's-
did you put?
well, we put the top one.
Oh, I
Oh.
guess it's the middle one then.
the middle one, guys.
Can
Can
we
we
go through and redo it?
Way to,
0.0052, right?
If we change it on here, can we resubmit it through this thing, or
oh,
no? We
can you? You
I
can.
don't know. We can?
Uh,
No, we can't. I don't know how to do it.
okay, well, I have all the answers. You're welcome.
Yeah, let's do this.
I'm just
So number 4 is B. So we can write that down real quick.
Four is B. Yes. So don't put what I have written there.
Okay, and I'll take the test again. I'm so glad there's 2 attempts. That's like
And I'm
awesome.
so glad that I have you guys.
I know me too, I'd be so lost.
Oh my gosh. Yeah.
Yeah.
But was there any ones we should like? Everyone this all makes sense to everyone mostly.
I always say after these quizzes, it makes more sense like when I'm working them out with you guys. I always say I need to go through and
Yes.
write down.
Yes, Laura, I think you're a great help demonstrating then how to do that on the board.
I think it's great that I get a board here. I should come here more often.
Okay. Group meeting quiz.
Perfect. That is what I like to hear.
My roommates are texting me. They're like, Laura, I need you to come home so we can eat.
Yeah, if one equation doesn't work, try the next equation.
You guys all eat together.
Yeah, well, my roommate loves to cook,
That's
so we just
what
buy
I'm
her
doing.
food and she does it for us. So makes me happy.
You have lots of paper.
Okay. I can just read them aloud. You guys can tell me. Okay, so question 3 is 0.175. Question 4 is B. Question 5 is law of large numbers.
Sweet, sounds good. I'll turn this in for everybody.
1.04.
See ya.
What was that one?
1.045.
Okay.
Question 7 is 0.148. Question 8 is 2.338. Question 9 is 0.0097. Question 10 is approximately normal. Question 11 is 3.5. Woo! After all that.
I know, right? I'm just glad we were right.
I know. Question 12, 0.078. Question 13 is 0.005. Question 14 is 0.995. Question 15 is 0.055. Okay, I just want to make sure. Oh, wait. Yeah. Okay. So 13 is 0.005 and 15 is 0.055. Okay. Any questions?
Nope, I'm good.
Okay.
Submitting again.
Oh,
Well, the good thing is, if you get something wrong, you're still gonna get the highest score. So it's great. 100%, guys.
good job, Pete.
Happy day.
Nice
Awesome.
job, guys.
Have a good night.
Yeah, I'll go ahead.
Good night. See you next week.
Bye.
Same time.